we want to find the zeros of this polynomial, f of x equals x cubed minus 5x squared plus 2x plus 8. And so to do that, without the aid of a calculator, we're first of all going to use the rational zero test. And basically, the rational zero test says if this function has any zeros, they are going to be of the form p over q, where p is a factor of 8 and q is a factor of 1. Well, anything divided by 1 is 1, so this is going to boil down to be just the factors of 8. So the factors of 8 are plus or minus 1, plus or minus 2, plus or minus 4, and plus or minus 8. So these are the possible rational roots. So we're going to synthetically divide until we find one of these roots that works. So start back with our equation. We have 1x cubed, negative 5x squared, 2x, and 8. We're just going to use the coefficients. We're going to start down the list until we find a number that divides in evenly, and we're going to know that that's a factor if we get a remainder of 0. So let's try negative 1. I'll bring the 1 straight down. Negative 1 times 1 is negative 1. Negative 5 plus negative 1 is negative 6. Negative 1 times negative 6 is 6. 2 plus 6 is 8. Negative 1 times 8 is negative 8. And I do get 0 out. I got a 0 remainder. That means that x equals negative 1 is a 0 of this polynomial, and x plus 1 is a factor of this polynomial. Now what's the other factor? Well, the other factor is the leftover part in our equation that precedes the 0. So our other factor is x squared minus 6x plus 8. So to find the other zeros, we're just going to work with x squared minus 6x plus 8 and solve to see what that equals. So this factors into x, and I think we're going to have minus 2 minus 4. That will give us x squared. Negative 4x plus negative 2x is negative 6x, and negative 2 times negative 4 is 8. So that does indeed factor. And so if we set x minus 2 equal to 0, we get x is 2. Set x minus 4 equal to 0, we get x is 4. So the zeros of this polynomial are negative 1, x equals 2, x equals 4. The factored form of this polynomial is x plus 1 times x minus 2 times x minus 4. Now note, if we go back and look, the degree of our polynomial was 3, and that means that we should have had 3 zeros, provided that we can triple this appropriately as not a single root. And so that is how we would use the rational zero test to get us started to solve this polynomial and find its zeros.